Let's look at this problem. Tangent and normal at the ends A and C of a focal chord AC of the parabola y square equal to 4x intersect at B and D. Then find the minimum area of the quadrilateral ABCD. Okay, so here what we are given is a parabola y square equal to 4x is given, and there is a focal chord AC. Let's say there is a focus S. So if I draw tangents at this point, so they are intersecting at B, and if I draw normals at these points, at A if I draw a normal, and at C if I draw a normal, so these normals are intersecting at D. So we have to find minimum area of this quadrilateral ABCD. So the given parabola is y square equal to 4x. So I will consider parametric points. A is t1 square comma 2t1, B is t2 square comma 2t2. So equation of tangent at A is t1y is equal to x plus a t1 square. Here A is equal to 1, so t1y is equal to x plus t1 square, and again at t2 is t2y is equal to x plus t2 square. If I solve for the point of intersection of these two, so I will get the coordinates of B as, so if I find this, I will get t1 t2 comma t1 plus t2, t1 t2 comma t1 plus t2, because if I subtract these two, I will get y is equal to t1 plus t2. If I put y is equal to t1 plus t2, x equal to t1 t2 I will get. So I got B. This is C, no? Again I want to find D. So I want equation of normal now. So equation of normal is tx plus y is equal to 2at plus at cube. So t1x plus y is equal to 2t1 plus t1 cube, because a is equal to 1. Again t2x plus y is equal to 2t2 plus t2 cube. So if I solve these two, I will get D. So D is, so subtract these two, y will be eliminated, x equal to 2 plus t1 square plus t2 square minus t1 t2, right? Yes or no? So because if I subtract these two, t1 minus t2 will be there, so 2 plus t1 square plus t2 square plus t1 t2 comma, if I substitute that here, so I will get minus t1 t2 into t1 plus t2. So if I substitute everything here, t1 into 2 plus t1 square plus t2 square plus t1 t2 plus minus t1 t2 into t1 plus t2 is 2 t1 plus t1 cube. Okay, this is done. t1 t2 square, t1 square t2, yeah, that is sufficient. So now we have A as t1 square 2 t1, B is t1 t2 comma t1 plus t2, C is t2 square 2 t2, D is 2 plus t1 square plus t2 square plus t1 t2 minus t1 t2 into t1 plus t2. And as it is a focal chord, so for focal chord what can we write? So as it is passing through the focus, so AC is a focal chord. AC is a focal chord. So this implies T1 T2 is equal to minus 1. So T2 is equal to minus 1 by T1. So now we'll convert everything to one variable. So T1 T2 is equal to minus 1. So A is T1 square 2 T1. So B is minus 1 T1 minus 1 by T1. C is 1 by T1 square minus 2 by T1. D is 2 plus t1 square plus 1 by t1 square minus 1, t1 t2 is minus 1, so minus of minus it will be plus 1, so t1 minus 1 by t1. Okay, so instead of t1 I will write t, so because writing t1 is may not be good option, so we will write t square comma 2t, bs minus 1 comma t minus 1 by t, cs 1 by t square minus 2 by t, d is t square plus 1 by t square plus 1 comma t minus 1 by t. Okay, so what can we do now? So area of quadrilateral ABCD I want to calculate. So area of quadrilateral ABCD. Okay, what can we do now? So is there a simple way to calculate it? Obviously, because ABD is a right angle triangle, BAD is a right angle triangle, because tangent and normal are perpendicular to each other. Yes or no? So BAD is a right angle triangle, and again BCD is also a right angle triangle. Okay, so if I want to calculate that, so area of, because that side lengths we don't know, no, AB and AD. So what we do is area of ABC, I mean triangle ABC plus area of triangle ACD, ABC, ACD. So if I add these two triangles, I'll get the entire quadrilateral, right? So area of triangle ABC is equal to half mod t square 2t minus 1 t minus 1 by t, again 1 by t square minus 2 by t, t square 2t. So this is half mod. So if I cross multiply this, t cube minus t, this is plus 2t, again plus 2 by t, minus 1 by t plus 1 by t cube, this is 2 by t plus 2t. So half mod, this is t cube plus 3t plus 3 by t plus 1 by t cube. Okay, so this is 1 by 2 into t plus 1 by t whole cube, right? Because t cube plus 1 by t cube, 3t square into 1 by t plus 3t into 1 by t square, the same, right? So area of triangle ACD is equal to half the same t square 2t, next 1 by t square minus 2 by t, t1 square plus 1 t square plus 1 by t square plus 1, t minus 1 by t, t square 2t. So this is half minus 2t minus 2 by t, next minus t, sorry, plus t minus 1 by t cube plus 2t plus 2 by t cube plus 2 by t. Here if I cross multiply, 2t cube plus 2 by t plus 2t minus t cube plus t. So that's half. So see for t cube terms, 2t cube minus t cube. So t cube again 1 by t cube. So 2 by t cube minus 1 by t cube is plus 1 by t cube. Next c for t terms. So 2t minus 2t, this will go t t 2t, so 4t, and then minus 2 by t plus 2 by t will go 2 by t will remain plus 2 by t. Here there is a mistake, I guess. If you see this, minus 2t minus 2 by t plus 1 by t, sorry, this is plus 1 by t. So if you see that, it will be 3 by t here. This is 3t 5t minus 3t. So this is also same 1 by 2 into t plus 1 by t whole cube. So area of quadrilateral ABCD is equal to half mod t plus 1 by t whole cube plus half mod t plus 1 by t whole cube. So this is mod t plus 1 by t whole cube. So the minimum value of that is, so t plus 1 by t is greater than or equal to 2, because if I apply AMGM, so t plus 1 by t by 2 greater than or equal to square root of t into 1 by t. So t plus 1 by t minimum value is 2. So minimum area is equal to 8, 2 cube, right? 8. As we have modulus, we can consider only positive sign.